In this example, suppose a line passes through the point -6, 3 with slope 2/3. Part A, write an equation for the line in point-slope form. Part B, write an equation for the line in slope-intercept form. As a reminder, point-slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. In the problem statement, we are given the coordinate point -6, 3, so that is our x sub 1, y sub 1, and our slope, which is our m value. We can simply take these and substitute them into our equation. So we're going to have y minus our y sub 1 value of 3 is equal to slope m 2/3 times the quantity x minus our x sub 1 value, -6. I have x minus -6, which can be written as x plus 6, so we'll leave our answer as y minus 3 is equal to 2/3 times the quantity x plus 6. Now we want an equation for that same line, but in slope-intercept form, which is y equals mx plus b. We do have our slope, m, but the b value needs to be the y-intercept point, and we don't have that point. We had the point -6, 3 given. So instead of trying to substitute values directly into slope-intercept form, I'm going to take my answer in part A and solve for y to write it in slope-intercept form. So I'm going to start with y minus 3 is equal to 2/3 times the quantity x plus 6. I'm going to distribute in the 2/3 to the quantity x plus 6. So y minus 3 is equal to 2/3 x plus 2/3 times 6. Now, 2/3 times 6, well, 2 times 6 is 12, divided by 3 is 4. So I have y minus 3 is equal to 2/3 x plus 4. And finally, I will add the 3 to both sides to solve for y. So that's going to leave me with my final answer of y equals 2/3 x plus 7. In this example, suppose a line passes through the points 0, 4, and 2, -4. We want to do the same thing and write an equation for the line in both point-slope form and slope-intercept form. This time, however, we're given two coordinate points instead of explicitly being given the slope. So we need to find the slope using the formula for slope, m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So our coordinate points here, 0, 4, we'll call that x sub 1, y sub 1, and 2, -4, we'll call that x sub 2, y sub 2. So let's go ahead and find that slope m. M is equal to y2, so we have -4 minus y sub 1, which is +4, all over x sub 2, that was 2, minus x sub 1, which is 0. So I have -4 minus 4, so we'll add the opposite, we'll have -8 on top divided by 2, and -8 divided by 2 is -4. So now we have our slope, m equals -4. So we can go ahead and substitute into point-slope form of a line using our slope on either coordinate point. So I'm going to choose the first coordinate point, and we're going to have y minus y1, so y minus 4 is equal to slope -4 times the quantity x minus x sub 1, which is 0. So here is my equation for the line in point-slope form. Now, just like the last one, to get to slope-intercept form, I can solve my equation in part A for y. So we'll have y minus 4 is equal to -4 times x. So here we don't really need to distribute because of the 0. And then I'll add the 4 to the other side. So y equals -4x plus 4 is my equation in slope-intercept form. I also want us to take a moment to notice that here, this is of the form y equals mx plus b, And we had our slope, -4, and we actually had our y-intercept given on this problem. 0, 4 is a y-intercept because the x value is 0, so the y value is 4, and we could have substituted that in directly.